Hello class. Picking up where we left off from, we're going to example C here. I already took the liberty of doing example C. We have y equals 2x minus 6 and we have the ordered pair 2, negative 2. So we substitute in negative 2 for y and we substitute in 2 for x. So we have negative 2 is equal to 2 times 2 minus 6. We bring down our negative 2. Negative 2 is equal to 2 times 2, which is 4, minus 6. Negative 2 equals negative 2, so your answer is yes. Now we're going to take a look at objective 4. Find solutions of an equation in two variables. How do we find ordered pairs that are solutions of an equation in two variables, x and y? First, we select the value for one of the variables. Then we substitute that value into the equation and find the corresponding value of the other variable. Use the values of the two variables to form an ordered pair. We have our x value, we have our y value. This pair is a solution of the equation. Example 4, complete the table below to find 5 solutions of y equals negative 3x plus 7. Now I took the liberty of doing these problems beforehand, and what I would do is I would explain them. Okay, now our x values are given to us. We have x as being negative 2, negative 1, 0, 1, and 2. So we take this equation here and substitute in the given value of x. Now at first I did this with the writing pen here, but it kept jumping. You see here how this ordered pair, this parenthesis is higher than the negative 2. So all of the rest I did, I typed it in. So we'll start here. We have y equals negative 3, and we'll substitute in negative 2 for x, plus 7. So we have y equals negative 3 times negative 2 is positive 6, plus 7. And 6 plus 7 is 13. Now our order pair is we put the x value first, which is negative 2, and we put our y value, which is 13. Now we come down to the second equation. Here we're going to take the same equation, but we're going to substitute in negative 1 for x. So we substitute in negative 1 for x, and we have y equals negative 3 times negative 1 plus 7. Negative 3 times negative 1 is positive 3, plus 7 is 10. So our ordered pair is negative 1, 10. Now we do the same for 0. Substitute in 0 for x. We still write the same equation again, but this time x becomes 0. So negative 3 times 0 is 0, plus 7, and y is equal to 7. So our ordered pair is x is 0, y is 7. Now we go down here and substitute in 1. We have negative 3 times 1, which is negative 3, plus 7 is 4. So our ordered pair is 1, 4. And finally we substitute in 2. We have negative 3 times 2, which is negative 6, and negative 6 plus 7 is 1. Our ordered pair is 2, 1. Now we come to objective 5. We want to use point plotting to graph linear equations. The graph of the equation is the set of all points whose coordinates satisfy the equation. Okay, now it's the point plotting method for graphing an equation in two variables. Number 1, find several ordered pairs that are solutions of the equation. 2, plot these ordered pairs as points in the rectangular coordinate system. And 3, connect the points with a smooth curve or a line. Okay, now with number 1 it says find several ordered pairs that are solutions of the equation. Typically we only find 3. Sometimes it's, very so often we will find more than 3, but we'll just stick to maybe about 3 to 5 solutions, and we will plot that. So we need to scroll down. Now we're going to take a look here. It says example 4, continue. Use the ordered pairs from the previous table to graph the equation y equals negative 3x plus 7. Now we need to go back to this previous table. And what I would suggest, I'm not sure in your course pack if the pages are right next to each other. If not, then I would suggest that you take out a sheet of paper and write down these ordered pairs to graph. Okay, now let's plot those points. Our first point is negative 2 13. So what we would do, we would start at the origin and move 2 to the left and 13 to the top. Now if you notice, we do not have 13 points here. So let's not graph the first one. Let's just go to the second one since we have at least 10 points. So we go to the origin. We go over 1 because the second point is negative 1 10. And then we will go up 10. So we will plot our point here. So we have negative 1 10. Next, we have 0. So x is 0, so we stay here at the origin. But y is 7, so we will go up 7. Okay, now we have 1 4. We start at the origin, we'll go to the right 1 and then up 4. And last but not least, we have 2 1. We will go to the right 2 and up 1. Now, these are the points that we graph here. Now I have to admit I do not have a straight edge, but I will try my best to have as straight of a line as possible. Okay class, as you can see here, I put a line here and the line goes through all the points. It forms a straight line. Now we scroll down and we go to our next equation here that we need to graph. Now we have y equals x. Now what we could do here, we could just draw a table. We got x on one side and y on the other. Now typically I use 3 points. When it's something this easy, as far as the equation is concerned, I use negative 1, 0, and 1. So what we do is this here. We substitute in negative 1 for x, and your answer here is negative 1. So when x is negative 1, y is negative 1. Now we go back to the same equation. This time we're going to substitute in 0 for x. And we have y equals 0. So when x is 0, y is 0. Now we go in and substitute in 1 for x. So we have y equals 1 and y equals to 1. So when x is 1, y is 1. Now we need to go and plot those points. We start at the origin. We have x is negative 1, y is negative 1. Next we have 0, 0. That is the origin. So we put a point right there at the origin. And then next we start at the origin. We go to the right 1 and up 1. And now we will draw our line. Again, here's a visual representation of the line being drawn here. You can extend the line, but you don't need to. The arrowheads let you know that it goes on forever. Now we scroll down. Now we come to example 6. Now we could put our XY table here. Now I still like to use 3 points, but I'm going to attempt this a little differently here. Because we're dealing with a fraction, this is what I would do. The fraction is connected to x. So one of the values I would use is 0 for x. The next 2 values I will use is whatever the denominator is, the positive denominator and a negative denominator. So I use positive 2 and negative 2. Now I will explain why I do this as we go through the problem. So first, we will have y is equal to negative 3 halves times 0 plus 1. Negative 3 halves times 0 is 0. And we know 0 plus 1 will give us 1. So when x is 0, y is 1. Now we're going to go through and substitute in 2. So we have y equals negative 3 halves times 2 plus 1. Now, these 2's will simplify each other out and leave you negative 3 and plus 1. So y is negative 2. Now the reason why I use 2 as our denominator is because what will end up happening, these 2's will simplify out and it will leave you with an integer. Now we're going to use negative 2. So we have y equals negative 3 halves times negative 2 plus 1. Now again, these 2's will simplify out, but you still will have a negative 1 here. Negative 3 times negative 1 will give you positive 3. And 3 plus 1 we know is 4. So when x is negative 2, y is 4. Now we will graph that. We have 0, 1. We start at the origin, go up 1. That's 0, 1. And then now we have 2, negative 2. Start at the origin, go 2 to the right, and then we go 2 down. Plot that point. Now we add negative 2, 4. We start at the origin, we go 2 to the left, and we go 4 up, and plot that point. Now we need to graph the line. Now as you see here, we plotted the line here. So now we scroll down to the next problem. It says select another point on the line and show that the ordered pair satisfy y equals negative 3 halves x plus 1. Okay, now we could do this. We could do another chart, and they want us to do one more point. How about we use the number 4? Okay, so we have y is equal to negative 3 halves times 4 plus 1. Now if we use cross simplifying, 2 goes into 4 twice, and negative 3 times 2 is negative 6 plus 1. So y is negative 5. So when x is 4, y is negative 5. So now we go back up here. So now we can go and plot this point. We go to the origin, we go 4, and then we go down to negative 5. And as you all can see here, if we extend this line, it will cross this point here. So that actually works. So now we come down here to see. It says select another ordered pair that doesn't lie on the line and show that the point doesn't satisfy this here. So what we could do is this. We could just select some values at random. Let's try 6 and 7. Now to prove that this doesn't lie on a line, we could just substitute in these values here. Okay, now we'll substitute in 7 for y, and we'll substitute in 6 for x. 2 goes into 6 3 times. 3 times negative 3 is negative 9 plus 1. 7 is equal to negative 8. And we know 7 does not equal 8. So that shows that this does not satisfy the line, because remember, this point here must make both sides equal to each other in order to be on this line. So we just proved it. Now we scroll down here to example 7. It says objective 6, use graphs of linear equations to solve problems. Okay, we're given this equation, s equals 2.4n plus 31. You can read the description at your leisure. Now, what we're supposed to do, and I filled this in already, we were supposed to do like we did in the other problem earlier. We were given some values here, and we just substitute the values into the equation. And then we would get our ordered pairs. Now, what you would need to do, I'm going to scroll down, hold it for a second, and then scroll back up, and you need to copy this into your course pack. So if you need to pause it, pause it. Now with example 7, I will graph that in just 1 second. Okay class, there was a little error with the 15. It's supposed to be, y is supposed to be 67, not 36. So make sure you make that change. Down here I have my graph. I use n scale of 5, and then also use the scale of 10 for s. And I drew my graph. Finally, here's the answers for C and D. You could pause this and you could have these answers available to you. Thank you.